Start now. So in today's discussion, we are going to interact on the topic Laplace Transform. Laplace is a person who introduced this concept, Laplace Transform. Laplace Transform is used on functions which has two properties. So suppose if you take f of t as a function, it should have two properties. It should have two properties. Number one, first one is it should be piecewise continuous. It should be piecewise continuous. It should be piecewise continuous. The second property, any one of you? What is the second property? It should have exponential order. It should have exponential order. It should have exponential order. So if a function satisfies these two properties, then we can apply Laplace transform on this function. Okay. Then why do we need Laplace transform? So what is the importance of Laplace transform? So next is Laplace transform is important in solving complex problems which occurs in real-time engineering. So it is used as a tool like other transformers. We have Fourier transform, we have Z transform, like there are various transforms. Such one type is Laplace transform. Laplace transform does the work of solving or as a tool to analyze, to understand the properties of complex scenarios also. But the thing is, the function should have these two properties. Okay. And also Laplace transform is applied on periodic functions and in various areas. So what is the importance? That is what we saw now. Next is, what is the definition of Laplace transform? So Laplace transform deals with the formula Laplace of f of t is equal to integral 0 to infinity e power minus st f of t dt. Okay, this is the formula, this is the definition for Laplace transform, where you know the integration should have region from 0 to infinity. This is the range for which you can apply Laplace transform. But when we discuss Fourier transform, it involved minus infinity to plus infinity. Here it is 0 to infinity. So the next thing is there any standard results in Laplace transform? Yeah, we have some standard results in Laplace transform, like various different types of functions. We can apply Laplace transform in various functions, like step-up functions are there. Then we have unit functions are there, unit impulse functions are there. There are multiple functions in real-time engineering. So in these functions we can apply Laplace transform. Also, Laplace transform is a very good tool to solve differential equation problems. Okay, in solving differential equation problems, because you all know differential equation plays a vital role wherever you talk about rate of change. So wherever in engineering you come across rate of change, we will use differential equations. So in order to work with differential equations, we can use the concept of Laplace transform. So in that way, we have, for example, if you take Laplace transform of e power at, I was telling you, e power at is the exponential function. So if you apply Laplace transform for this, what we get? 1 by s minus a. 1 by s minus a. Similarly, Laplace transform of e power minus at is equal to 1 by s plus a. Likewise, we have multiple standard results in Laplace transform. Okay. So likewise, we can work on various exponential functions, various trigonometric functions. Even we can apply Laplace transform on trigonometric functions. For example, Laplace of sin at, Laplace of cos at. So likewise, in trigonometric functions, even we can apply Laplace transform. Even there can be a combination of the exponential and trigonometric function. For example, Laplace of e power at cos bt.